So the first thing we need, the first thing that's necessary for properly diagnose these diseases is to have more data, more information. What is done today in clinical practice is the use of, for example, magnetic resonance imaging, also known as MRI, as you can see here, or if you want to look into the structural information of the brain, or if you want to look into functional information of the brain, we have fMRI, the functional magnetic resonance imaging systems. So these two are conventionally used and routinely used today in hospitals, but the resolution they have is certainly not enough to properly diagnose these disorders. Apart from detecting, for example, brain aneurysma, which is very useful, these kinds of tools are fundamental, but again, very limited to some specific applications, for example, on detecting this or encephalopathies, but not, for example, looking into the neuron cell for diagnosing Parkinson's. Some typically used in clinical practice, we have electroencephalograms, and again, PET scans or position emission tomographies. And once again, they're very limited in terms of resolution to the brain. These tools are very powerful to look into organs like kidneys or the stomach or your heart, because cells are not important. Individual cells don't play a key role on the functioning of these organs, but they do on brains. So that's why these tools are not enough for clinicians to properly diagnose and understand what's going on the patients. That's on the clinical practice. At the research level, we're starting to use microletter arrays, larger and larger with bigger numbers. And one of these microletter arrays was, for example, used in research, at the research level, to empower a monkey to control a robotic arm autonomously.